Welcome to 1 Minute Tech, your channel for the latest and most precise updates from the world of technology. In today's video, we bring you an in-depth look at how Apple is leveraging artificial intelligence to reshape the future of chip design. This transformative move is not just about enhancing speed or efficiency. It represents a fundamental change in how Apple approaches silicon innovation. Let's explore the details of this groundbreaking strategy. Apple is now actively exploring the use of generative artificial intelligence to accelerate its custom chip design process. Johny Srouji, Apple's Senior Vice President of Hardware Technologies, has highlighted that these AI techniques have what he describes as high potential for enabling more design work to be accomplished in less time. According to Srouji, this shift could deliver a huge productivity boost to Apple's silicon development operations, which are crucial to maintaining the company's competitive edge in the hardware industry. The introduction of AI into chip design marks a significant shift in Apple's development methodology. The company is aiming to transform what traditionally have been years-long chip design cycles into a matter of months. This strategic initiative focuses on automating the repetitive tasks that typically consume considerable engineering time and effort. By doing so, Apple's design teams can redirect their focus toward higher-level design decisions and more creative problem-solving, rather than the time-intensive manual optimization work that has long been part of chip development. Johny Srouji shared this vision during a ceremony where he received an award from QiMeng, a well-known semiconductor research organization. In his remarks, Srouji reflected on Apple's silicon journey, tracing its progress from the debut of the A4 chip back in 2010, through to today's advanced processors that power Mac desktops and the innovative Vision Pro headset. His comments underscored how AI integration represents the next stage of evolution for Apple's hardware technology. By accelerating design timelines, Apple stands to benefit in several key ways. The company could achieve significant cost savings, reduce supply chain bottlenecks, and strengthen its ability to maintain the seamless integration of hardware and software that is a hallmark of its product ecosystem. As these AI-driven design tools are exposed to more and more data from existing chip architectures, their ability to optimize designs is expected to improve substantially over time. This could further reinforce Apple's leadership in the field of custom silicon innovation. A critical component of this strategy is Apple's collaboration with leading electronic design automation companies. Cadence Design Systems and Synopsys are essential partners in the development of AI-powered chip design tools. Both companies have been working intensively to incorporate artificial intelligence capabilities into their software platforms. Srouji emphasized that these EDA companies are supercritical in supporting the complexity of Apple's chip design requirements, pointing to the indispensable role they play in this ambitious initiative. Cadence has developed its Joint Enterprise Data and AI Platform, or JED-AI platform, which marks a generational shift from traditional single-run algorithms to AI-driven optimization that spans the entire system-on-chip design flow. This platform supports a more holistic and data-informed approach to design, enabling enhanced efficiency and better outcomes. The company's financial performance has reflected this strategic pivot, with Cadence reporting a 27% year-over-year revenue increase in the fourth quarter of 2024. This growth was driven in part by the widespread adoption of their AI-enhanced design tools across the semiconductor industry. Synopsys has also made substantial advances with the introduction of its Synopsys.ai suite in 2023. This comprehensive suite offers AI-powered solutions for digital and analog design optimization, verification coverage analysis, automated test generation, and more. It allows engineers to apply artificial intelligence at every stage of the chip development process. Notably, 9 of the world's top 10 semiconductor companies have already integrated Synopsys.ai into their workflows, underscoring its value and relevance in the industry. Another key element of Apple's design philosophy is its willingness to take bold technological leaps without fallback options. This approach was especially evident during the transition of Mac computers from Intel processors to Apple Silicon in 2020. According to Johny Srouji, the company adopted an all-in strategy with no backup plan and no split-the-lineup plan. This decisive commitment reflects Apple's confidence in its design capabilities and its readiness to fully embrace transformative technologies when the potential benefits justify the risk. That same mindset now shapes Apple's exploration of AI-assisted chip design. Srouji suggests that integrating AI into the design process could represent a similarly transformative step, enabling more efficient workflows and helping Apple maintain its technological edge in an increasingly competitive field of silicon development. Meanwhile, as Apple pursues these innovations, significant advances are also unfolding in other parts of the world. In China, researchers have introduced QiMeng, a system described as the world's first fully automated AI-powered processor chip design platform. Developed by the Chinese Academy of Sciences, QiMeng has already delivered impressive results. QiMeng No. 1 completed the entire front-end design of a 32-bit RISC-V CPU in only 5 hours, achieving performance comparable to an Intel 486 processor and integrating more than 4 million logic gates. Building on this success, QiMeng No. 2 has produced a fully automated superscalar processor with 17 million logic gates, delivering performance on par with an ARM Cortex-A53. The QiMeng system is structured across 3 layers and includes a large processor chip model as its foundation. This architecture helps address challenges like limited data availability and the complexity of chip design knowledge. Looking ahead, Chinese researchers aim to enhance QiMeng's capabilities further by targeting 3-nanometer process nodes and expanding partnerships with foundries to accelerate practical implementation. These developments come at a time when the U.S. has placed export restrictions on EDA technologies to China, intensifying the global competition for leadership in AI-powered semiconductor design automation. This dynamic landscape highlights how artificial intelligence is rapidly reshaping the semiconductor industry worldwide. Apple's efforts to integrate AI into chip design are part of a broader technological race that is redefining how advanced processors are conceived and built. As these initiatives progress, they will likely influence not only the future of Apple's products but also the evolution of the global semiconductor ecosystem. Thank you for watching 1 Minute Tech. If you found this detailed report valuable, please like this video, share it with others who follow cutting-edge technology news, and subscribe to our channel for more in-depth updates on innovations shaping our future. Stay tuned, and see you in the next video.